Hi, in this video, we are going to just see a short concept. What is the basis of hemolysis in pyruvate kinase deficiency versus G6PD deficiency? Let's see what happens in pyruvate kinase deficiency. Pyruvate kinase is an enzyme of the glycolysis pathway. The major purpose of glycolysis pathway is ATP production. So, when there is an enzyme deficient in glycolytic pathway, there will be a decrease in ATP production. As a result of decrease in ATP production, all processes related to ATP will be affected. One major function is the sodium potassium ATPase pump, which is a primary active transport mechanism dependent on ATP as energy source. This particular pump will become dysfunctional. And cellular integrity of RBCs is maintained by membrane-bound ATPases, and one such is the sodium potassium ATPase pump. So once that is dysfunctional, there will be loss of cellular integrity in the RBCs, which leads to hemolysis. Let's see what happens in G6PD deficiency, glucose 6-phosphate dehydrogenase deficiency. This is an enzyme of the hexose monophosphate shunt pathway or the pentose phosphate pathway. The major purpose of this pathway is NADPH production. How NADPH production affects the RBC membrane integrity is what we will see next. So, NADPH is produced as a part of HMP shunt pathway. What is the role of NADPH? So whenever there is any oxidant stress inside the cell, like certain drugs, infections, and ingestion of fava beans, there will be increased accumulation of free radicals such as hydrogen peroxide. So we need to detoxify the hydrogen peroxide. For that, we have enzymes glutathione peroxidase, which is going to detoxify the hydrogen peroxide. During that time, it converts the reduced glutathione to oxidized state. So now we need to regenerate the reduced glutathione back in order to scavenge more free radicals. So we need the enzyme glutathione reductase, and this glutathione reductase requires NADPH. So in case of G6PD deficiency, there will be reduced production of NADPH. So glutathione will not be converted from oxidized state to reduced state. As a result, a lot of free radicals will begin to accumulate, which will damage the RBC membrane, and thus the RBC will lose its membrane integrity, which leads to hemolysis. So this is the basis of hemolysis in G6PD deficiency.